Hey everybody, this is Larry. This is me Friday night here. Uh Leetcode Daily Challenge. What day is this? Let's see. My internet is a little bit slow. Day 26 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem, Stone Game 2, 11:40. Yeah, so I'm a little bit late. I've been traveling all day. I'm gonna be traveling all day tomorrow too, so hopefully we'll see what happens. But anyway, yeah, so the contest will probably come pretty late, the videos, but whatever. It is what it is, you know. And if you want to know what I'm up to, follow me on Instagram. The link is below somewhere. Anyway, today's poem is, like I said, 11:40 Stone Game 2. So Alice and Bob continue, it was a game of stones. Okay, so they're piles. M is equal to 1. Can take all the stones in the first X remaining piles, where X is equal, and then we set M is equal to max of MX. Say what? What is M? Oh, M is 1, so you can take initially 1 and 2, and then M is set to the maximum. Okay, I mean, okay. Okay, so M is 1, and then if you take 1, okay. Powers is only 100, so you could probably be pretty lazy with the things. Okay, a couple of things first. First of all, this is a symmetric game, right? And what that means is that given it's not quite mathematically this way, but it is that it has the same rules for both Alice and Bob, right? I mean, there are other stuff there are other implications as well, but that's the first one. So then, okay, so for example, I think one of the states is calculate. Let's just say calculate or whatever the state, and so then now. What do we take? The first one, the first X file. So here we only care about the suffix, right? Because you're always going to take it from the beginning. So here we can do the index that we start at, and then we can say the current M. And I think that's pretty much it, right? Yeah, because nothing else really matters. So then here, and like I said, it's a symmetric game, so that means that it doesn't matter whether it is Alice going or Bob going. They have the same rules, right? And the core part of this idea or this game theory thing is called minimax, right? Because every point and every dimension of a point is the same. What I mean is that in some other games, like maybe you have to, do some balance between two things, right? Like, I don't know, apples and oranges or something, right? In this game, everything is worth exactly the same. Alice 1 point to Alice is worth 1 point to Bob, and you're trying to win. And in this way, this game, and I'm really skipping a lot of stuff because game theory is, I don't know, I wouldn't say it's hard, but it's something that when you learn, there's just a lot of stuff, right? And basically the idea is that to maximize your chance of winning, you want to maximize your number of points, and you also want to minimize the opponent's points, and because they're all worth the same and all this stuff, right? So yeah, okay. So given that these are the states, and it doesn't matter who it is, then like we said, we're trying to maximize our points and minimize the other opponents. And basically, given M, we can take X, right? So for X is in range, so we have to take 1 pile or 2 times M plus 1, just to be inclusive, right? And basically, so now that you've taken the first X piles, what does that mean? That means that you take, let's just say, and we're going to do this with a prefix some kind of way so that we don't keep on going nuts. But basically, current we added to piles of index, plus x minus 1, just because of the way that we did the things, right? And then, so the current is the score of that we got, right? So, yeah. So then now we calculate by doing index plus x is the next offset. And we have to be a little bit careful. Well, this is better in C++ style for loops, but yeah, but if this is greater than or equal to n, then we break, right? N is equal to length of piles. Basically, we just ran out piles, right? So basically, yeah. So the thing that we're trying to minimize is this thing, and so this is the points that we get. This is the points that this is the points that your opponent gets. So you subtract them to kind of maximize the delta between your point and your opponent's point. And yeah, and now your best is equal to actually I guess negative infinity in this case, right? And then best is equal to max best of this thing, and then at the end we return best, and that's pretty much it, really. Oh wait, I messed up. Hang on. One. I messed up is that we have to update m, and m here, as we said, we basically max up m and x, right? Yeah. So that's basically it, I believe. Let's run it real quick. I know that we didn't. Whatchamacallit? We didn't memorize yet, but let's see. I guess, yeah, I forgot a base case maybe. Basically, once you take in all the things, then it should be 0. Yeah, -6. Oh, of course. So this is the score that Alice and Bob, or Alice score minus Bob's score after we play maximally. So this is going to be the delta is equal to this thing, right? And then total is going to be the sum of piles. So then you kind of do the math. So you have, Bob. So Bob plus delta is equal to total, right? This is just mathematically, not a programming thing. So that means that you have to be or not to be, whatever. So this is this, right? So then Bob is equal to this minus delta. So then Alice is equal to Bob plus delta, right? I think I messed this up. I think this delta should be a plus. So okay. No. Yeah. I messed this up. This should be Alice. So that means that, okay. That means that we return total minus delta divided by 2, and that should be good. Maybe, hopefully. Huh. Apparently, I do not know how to program. 18. Let me see real quick. I mean, it's also possible that I'm like off by 1 somewhere, of course. 26. Yeah, I mean, that doesn't even make sense. Total. No, what does -6 mean? I mean, I know that I can fix this, but did I messed up? Oh, I see, because this is, because we have to do the first one, which is calculate Alice. So then this is, now to get that score, the delta is in the perspective of Bob, And then now, okay, fine. Okay, I see. That's tricky actually, but that's why we test things. Yeah, and of course this is going to run exponentially. But we do something called memorization. Index can go from 0 to n. M can just go from 0 to. I mean, technically it could go really big, but effectively it's 0 to n because once m is bigger than n, then you ran out of things anyway, right? So we can actually even write it this way, right? So that we, yeah, right? Because once m is n, or if m is bigger than n, then it is effectively n anyway, right? So yeah, so that means that this is going to be O of n squared number of inputs, and each input we do a O of n loop here. Like I said, this also, I mean, it's m, but it's also maximum n, right? Because after that you just break anyway. So that means that total running time is O of n cubed, which for n is equal to 100. This is good enough, right? So yeah, so now we just have to add the cache. So let's do it. Has cache is equal to force times n, right? Something like this. Yeah, fine. Yeah, add one just in case. I don't. I'm trying to. And this is how I generally do it for teaching purposes. So you know, but yeah, it has cache of index and m. Oops, m. Then we return cache of index and m. Otherwise, you know, we just set up the index, and that's pretty much it. Maybe I don't know. Well, let's actually submit it first before I say that, because I feel like sometimes, you know, and you can see that my internet speed is a little bit on the slower side. But yeah, that's pretty much it. Just let me know what you think. Yeah, tomorrow I'm gonna be in Armenia, so I'm excited about that. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye. Forgot to press the button.